Good evening, students. Today we have solved two problems. The solutions for no load current problems are very important. In this respect, we are having 3 to 4 problems. Two problems are very important. They have been asked a number of times in PTO examination and go on practicing. Okay, yesterday we have discussed the estimation of no load current for single phase transformer as well as 3-phase core type transformer. So problem 1 is given like that. If you are having time, you go on writing given data one side. So in this problem, AGI is given, gross core area is given, stocking factor is given. First step, go for net iron area. Net iron area we are getting 2.25 times 10 to the power of minus 3 meter square. So it is also known that primary voltage or indeed the EMF of primary is equal to 4.44 times F phi m into Tp. So phi m is also equal to Bm into Ai because our intensity is to calculate the flux density. So already you are knowing all the values. Substitute. We are going to get as 1 Bm equal to 1 Webers per meter square. So after knowing this one Bm and Ai, then it is very easy to calculate flux. Flux in core equal to B into A, flux density into area, because B equal to phi by A. Use that relation. So we are going to get as 2.25 into 10 to the power of minus 3 Webers. The following relation is very important to solve the next step of the problem. So it is well known that reluctance is equal to MMF divided by flux. So which is analogous to the resistance in electric circuit. So the reluctance is also given by in terms of area and length, L divided by mu times A. L divided by mu naught mu r A, absolute permeability, relative permeability and cross sectional area where L is length. So this relation can be used for next step solution. So total magnetizing MMF AT naught equal to reluctance into flux. So reluctance value you substitute from the top expression, Li length of iron, Ai area of iron. So here core is not given, yoke is not given, sum of that word is used, iron, length of iron, area of iron. So reluctance into flux phi m. After that, the ratio of phi m by Ai, the ratio of phi m by Ai in the above equation becomes Bm. Then you calculate the AT naught. You calculate AT naught. We are going to get 1980 angstrom. Magnetizing current Im equal to AT naught divided by Tp into root 2. So given transformer is single phase, hence there is no problem. Go on substituting the values, we are going to get as 1.75 ampere. So after that, to calculate the no load current, I need iron loss. So the next steps are to calculate the iron loss. So very first we have to calculate volume of core. Volume of core equal to area into length. Area of iron into length of iron, length of flux path in iron. So that should be equal to 2.25 into 10 to the power of minus 3 into 2.5. So we are going to get 5.6 into 10 to the power of minus 3 meter cube. Then the weight of core equal to volume into density, because density is in kg per meter cube. Volume meter cube we are going to cancel, remaining is kg. So we are going to get as 43.8 kg. The iron loss is also given. It is watts per kg. It is watts per kg. Hence you multiply kg. Watts per kg into kg. Kg will going to cancel. Remaining is watts. That is around 144 watts. So by knowing the iron loss, by knowing the Vp, then it is easy to calculate loss component. Loss component of no load current, IL equal to 0.25 ampere. Once you are knowing the magnetizing current, once you are going the loss component current, then it is very easy to estimate, go for no load current. I0 equal to under square root of Im square plus IL square. So we are going to get around 1.77 ampere. Second problem, it is very important. Number of times same problem was asked in PTO examination, minimum 10 marks. All data you write down one side in symbol, what is the details are given. So later on you can go for the graph. You plot the graph BM, you take the BM as x-axis, mmf per meter as y-axis. On same y-axis iron loss, watts per kg. Y-axis you keep these two components, x-axis as BM. You plot the graph. AGI is given, gross core area or gross iron area is given 10 into 10 to the power of minus 3 meter square. So stacking factor is also given. Stacking factor is also given. Then it is very easy to calculate AI, net iron area. Net iron area calculate. Once you are knowing the net iron area, go for calculation of flux. Go for calculation of flux in core. Again by using primary induced EMF expression EP equal to that one already you are knowing. So after calculation of phi m, we are knowing the phi m, we are knowing the AI. Then next step, calculate the flux density. Flux density Bm equal to phi m divided by AI. So we are going to get approximately around 1 Webers per meter square. So I told to plot the graph. So corresponding to this value, flux density of 1 Webers per meter square, small at mmf per meter is 210 angstrom, and y-axis another component loss per kg is 1.3 from the graph. So in this problem these two values are directly available from the table only, take down, no problem. But if the flux density is intermediate value, then you have to go for reference of graph. Go for reference of graph. Hence, getting the idea, this BAT curve is supplied from manufacturer. Another important part, mmf for iron path. So in this problem, core is not given, yoke details are not given. He used the word iron. That includes both mmf for core, mmf for yoke. So this gives mmf for iron. Hence mmf per meter of iron into length of flux path in iron. So that you are going to get general 210 into 2.2, 462 angstrom. You observe very clearly, in generally we are using core and yoke separately. In this problem he used iron, mmf for iron path. It is algebraic sum of both mmf for core, mmf of yoke. Generally used the word mmf per meter of iron. So in general MMF for joints. MMF for joints is also given by 800,000 times Bg Lg angstrom. So 800,000 times flux density is 1, Lg is 0.2 mm, length of air gap. Usually it gives in mm, dimensions of mm, but all other factors are in meters. That's why you convert Lg into meters. 0.2 divided by 1000. So we are getting 160 angstrom. We are knowing the MMF of iron, we are knowing the MMF of joints, then you go for total magnetizing MMF. Already we are knowing the expression total magnetizing MMF equal to MMF of core, MMF of yoke plus MMF of joints. So already I told that same thing, MMF of core, MMF of yoke, it is generally referred as MMF of iron. Hence MMF of iron plus MMF for joints in this problem. So it becomes 622 angstrom. Then magnetizing current or reactive component of no load current. So magnetizing current is equal to 80 naught divided by root 2 Tp, where Tp is number of primary turns. Again, given problem is of single phase. You substitute all the values, so the magnetizing current is 2.2 amperes. To go for calculation of loss component, very first step, calculate the volume of core. Volume of core equal to AI into Li, 0.0198 meter cube. Then weight of core equal to volume into density. Volume into density, we are going to get kg, 155 kg. Total iron loss per kg into weight in kg. Kg will going to cancel, remaining is watts. So 201.5 watts. Once you are knowing the total iron loss, again given transformer is single phase, calculate loss component of no load current, that is equal to Pi divided by Vp. Pi is total iron loss, Vp is primary side voltage, so we are going to get around 0.5 ampere. Hence no load current becomes under square root of, again general expression, Im square plus IL square. You substitute the values, then we are going to get as 2.26 ampere. Search. In this concept, either derivation may be asked in examination or problems. One part will definitely come. Already we have solved 2 problems. Another 1 or 2 problems are there. Out of this 4 hours work, one will come in exam for 10 marks. So be careful, practice the derivation, practice the problems. Third problem we are going to solve tomorrow or next class, that is of depends on purely on derivation. So flux density of core, MMF per meter of core, flux density of yoke, MMF per meter of yoke. Getting the idea? It is purely of derivation. So you have to derive, understand the equation properly, then next problems becomes very easy. Thank you to one and all.